Did you know that you've never been in the same place twice in your entire life? Because think about it. You're on a planet, spinning and revolving around like a top, orbiting around a star. The sun moves around the Milky Way, and the Milky Way is on a collision course with the Andromeda Galaxy. They're drifting towards each other inside of a supercluster of galaxies that are all in constant flux. So you've never been in the same place, in the same location, twice. So that begs the question, where are you? And that is exactly what Chapter 3 of Majesty and Monotony is all about. So I had a lot of fun with this chapter, actually, primarily because the contents of this chapter are essentially what I did for work for a good 2 to 3 years working inside of planetarium, both in Colorado and in Boston. And what that entailed for a lot of the shows that I did, whether they be music-based shows or just entertainment shows in general, or educational shows, would be to start off on the planet. We would lift off of the Earth and gradually zoom out all the way to the cosmic microwave background, which would be the edge of the visible cosmos. And being a 46 billion light year journey, I'm sure you can imagine there's plenty along that way to see, to observe, and to study. And the hardest thing, I think, for most folks when it comes to the scale of the universe, when you just hear someone talk about it, it's very challenging because the numbers are so vast, the scales are so large, and in comparison to us, it's beyond comprehension for most folks, which is why, as a slight digression, planetariums are so useful. It's because they can actually help you visualize that in real time, being able to travel faster than light speed, zipping from the Earth to the edge of the universe. But we didn't exactly have that luxury in the form of a book, and so that's kind of why I'm especially excited and was I had a lot of fun writing this particular chapter. So my main goal was to help folks to be able to visualize these scales and these numbers relative to terms that are accessible to anyone from their daily lives. So, for an example, uh, I go from what you can see across the horizon and then use that as a measuring stick to compare to everything else moving. So to give you an abridged version of what that looks like, you won't hear any numbers or exact calculations in this video just because that's what the book's for. And so if you're more interested in that, you can go and you can calculate numbers for yourself. These are all things you can look up with a quick search. But you can actually get the hard numbers on your own if that's something that you're interested in looking at. But just to give you an idea, looking at the horizon, obviously depending on your latitude and your height and those types of variables, most people can see somewhere in the neighborhood of 2 to 3 miles away if you look from where you're at all the way to where the sky meets the earth. So that would roughly translate to around 4 to 5 kilometers, and that's going to be the baseline that I use. From there, I uh, give the circumference of the Earth, something that's what you would learn in high school, just two times, I'm sorry, the radius squared times pi. And then from there, we jump to light speed. So if you were able to travel at the speed of light and you were to try and go all the way around the planet and you had 1 second to do so, you would actually be able to cover the entire circumference of the Earth a little bit over 7 times in that 1 second. And so once you know the circumference of the Earth relative to how far you can see to the horizon, now you can get a sense of what we mean when we're talking about light years, light minutes, light seconds. because despite what the name suggests, those are all measurements of distance, how far something is, based on how fast a massless particle would move, usually in the form of. From there, we zoom out to the moon, which is also a little bit over 1 light second away, then to the sun to get a sense of scale for our solar system, which in the case of the sun would be about 8 light minutes away from us. And already you can see how the scales are starting to grow exponentially. Just think about how many seconds there would be in 8 minutes. A little bit over 480, right? So now we're 480 times farther away from the Earth than our closest natural satellite, the moon. And we keep expanding out from there, all the way to the edge of the solar system, the heliosphere. Then we zoom out to the Milky Way, roughly a little over 100,000 light years, depending on who you ask. There's still a lot more research being done on that, but in school we go with 100,000 light years approximately. Uh, then out to our local group of galaxies, the Magellanic Clouds, again Andromeda, continue zooming out, and we begin seeing more and more clusters of galaxies that are only visible for high-powered telescopes, and that you'd only be able to see uh, using like telescopes that are orbiting around the Earth, that are far away, that aren't hindered by the Earth's atmosphere. Because I've made this journey so many times, both for fun and for work, I basically go through the entire universe tour as I would give it to a live audience, as I have given it to multiple live audiences, uh, over the entire journey. So I do my best to illustrate exactly what you would be seeing as you can watch the moon orbiting around the Earth, the planets around the sun drifting around the Milky Way, and how the shapes of the galaxies and the galaxy clusters sort of resemble neural structure in a lot of ways. They cluster and form webs and nets, and what exactly those different colors and structures and shapes you'd be seeing would look like and why. All the way up until we get again to the very edge of what you can see, the cosmic microwave background, uh, what that looks like, why that looks the way it is, and what it means for it to look the way that it is, and what that tells us about the history and structure of the universe we live in. And that's generally it. So you can get a sense of where things are relative to each other, and most importantly, where we are in the grand scale of the universe. And I'll end this video with a fun little story about one of the many universe tours I gave. Actually, not even for educational purposes. Uh, One of the music shows that is very popular in Planetaria is Pink Floyd, in particular Dark Side of the Moon. And the album, as any fan would know, ends with um, eclipse and brain damage, kind of blending into one another. And the way that I would always end shows, I would actually expand the planet, expand the Earth, so that way you're orbiting around the moon with the Earth sort of all around you. And while we were orbiting, the lasers were going off, I would load up a bunch of programs and visuals of local groups of galaxies, nearby galaxies, and a lot of extra data for supernovae, black holes, various types of discoveries that have been made. They pop up a lot of really cool shapes. And as as the song sort of crescendos, I zoom out, we're out of the Earth, and all of a sudden a big flash of all types of different colors of light, galaxies. A lot of them have been inflated to make the effects look cooler. And I just zoom out as the music continues to go all the way until you get to the edge of the universe. The microwave background looks like a sphere, and it eventually collapses, ending the song as the whole screen goes dark. And that I bring up because it sort of highlights the feeling that you get when you begin to understand what these scales of the universe look like and what our place in them is. And the best way I've heard it articulated, and what happened to be a huge compliment, was one of the patrons who had come up after one of my shows. This was back when I was working in Boston, and he walked up to me and he said that he saw the face of God after watching one of my shows. And I won't go into you know any opinionated discussion on what that would mean for an individual person, but I just thought it was a nice compliment that seeing the universe in a brand new light can be transcendental and in some ways spiritual. And so I thought that was a good segue into getting into the rest of the book because this will be the end of the first section, which is heavily science based, mathematical, calculated, based on actual research that I've done, research papers that I've read, um, and it's all about what I went to school for. Um, and from there, we're going to be going into more general topics of academia, why things are important to learn, say your social studies, your literature, mathematics, sciences, and how those things can be useful for anyone moving forward in their daily lives. So look forward to that. If there's any questions or comments that you have, then please feel free to share those. And um, if you are interested in purchasing a book, the link should be attached in the description of this video. And with that, I will wrap off this video. Thanks for watching and have a wonderful rest of your day. Bye-bye.